Okay, hi guys, looking good. Let's just check all the technical setup. Good to go. Okay, welcome back. Thursday, here we are, 5 o'clock, evening session, live maths, student's choice, homework club. So that's just me listing a few words, but maybe let's get going with it and try and do a few questions. Suggestions for what to do today. Yeah, I mean, if you've got anything in the chat, anything that came up today or you were looking at, came up with any new theorems that you want to be submitted to any of the for any important maths awards, or okay, if you just had any let's not joke about. If you just had any questions you were stuck with today, send them through to me or ask me about it. I'll try and explain them. Suggestions were coming in by the thimble load already. So people have been asking about stats, and yeah, let's do some stats today. I've just got one hypothesis testing question that I investigated, but if there's anything else in particular, you could let me know. Circle geometry, someone also mentioned. It's up and ready to go. Well, one type of circle-y kind of questiony thingy. Someone had someone asking whether I'm taking over from Rachel Riley on the popular Channel 4 game show Countdown. I am bound by confidentiality. I cannot comment on that right now. So I think you should just check the press and the tabloids for any more news on that. Proof by contradiction, roots of cubics, a few other topics. I can maybe get to them today. Sorry if not, but we'll see. We'll see how we get on, okay? Any other things you want help with, just shout at me. Bit of a delay as usual. Tech setup's not 100% yet for the video, but I'm going to get started, okay? And usually it catches up. So, this question, let me just draw it. Can't remember exactly where this one came from. I can't remember if it was an AS level paper or an A level one. It looks like kind of an early AS level-y type one, like one of the first kind of types you would get when you start your A level, because it's got a bit of straight line in it. So you've got your GCSE knowledge really coming out to play. Now, is that an L? Yeah, they're calling that L? I think they are. Unless my eyesight's failing me. X coordinate, you've also got that 0. And the first question they're asking is, show that PA is that. Okay, so that's PA, is that bit there. I guess they're saying, yeah, the line PA. Okay, fair enough. I'm up for the challenge. Well, our line L, they've told us, equals 2x plus 1. What else have they told us, by the way? Circle. They've told us the center of the circle. We'll try and sneak that in. That's the coordinates of A, which is the center of the circle. And they've given us the equation of the line. So what I would be inclined to do here is, firstly, whisper quietly to myself, a tangent and a radius meet at 90 degrees. Sometimes I've been told that I mutter that in my sleep. Just sometimes, radius and a tangent at 90 degrees. Oh, don't say 90, it's pi over 2, we've got to be radians. So if you're like me, you know that, and that's a circle theorem from GCSE. You'll also maybe know then that for perpendicular lines, which perpendicular means right angle, M1 times m2 equals minus 1, i.e. gradient of this guy times gradient of this perpendicular guy equal minus 1. Therefore, the gradient of this guy has got to be minus a half. Let me just do a mild bit of extra working on that to show you why, because the gradient of this fellow is 2 from your GCSE data bank, and so therefore you've got 2 times m2 equals minus 1, m2 being the gradient of our perpendicular guy, and so m2 equals minus a half. So that's how I got that. So you've got y equals minus a half x plus c, because remember, for any line, y equals mx plus c. And we've got the gradient, minus a half. Just need c. And what can we do? We'll plug in this point, which is 7.5, and that will give us c. So basically 5 equals minus a half times 7 plus c, times everything by 2 if you like. I mean, this is just personal preference. But it looks like c equals 7, well, that's 2c, 17 over 2. Putting that back in, y equals minus a half x plus 17 over 2 times everything by 2, y equals minus x plus 17. Move the x across. Oh, did I not times something? Wait a second. Oh yeah, times, so it's 2y. And then move the x across, 2y plus x equals 17. So that's just part A. Micro recap. Micro with some degree of speed, but not excessive. That's not really catchy. I need to work on it. Right. Let's all just be quiet and get on with it. There's a picture. There's a circle and a line. Touching each other once. That's a tangent. Oh, they told us it's a tangent. Well, that's helpful because a tangent and a radius intersect at right angles, as noted here. They want the equation of the line PA. By the way, you know, that's a full line, really, you would get. It's just goes through that radius, you know, it's in line with that radius, it's directly over the radius. Anyway, straight lines are y equals mx plus c. Just need m and c. M is the gradient, which is, since they're perpendicular, they've got to multiply to minus 1, so the gradient's minus a half. And c you can get by plugging in the point A. So that's what I did, and ends up with the correct answer. I'm going to keep going. I know that's a little bit fast, but we've got a lot to get through, and I want to check stats as well. So I'm going to have to keep going. So they want the equation of the circle. So, straight in. X minus a squared plus y minus b all squared equals r squared. I sometimes think that's what the birds are singing in the morning in their own language version of that. So that's not been corroborated, but I'm funding some research on the matter. For now, that is the general equation of any circle. The center point is AB, and the radius is R, if you like. So come along to me, tell me a radius and tell me a center point. I'll create you an equation for a circle. So here we go. I mean, I can get going already, because x minus 7 squared plus y minus 5 squared equals r squared. So they want the equation for the circle. It's 4 marks. I'm blooming halfway there, to be honest. I just had to have this carried in my head, and I had to pop in the A and the B, which is the centre. But okay, we do have to get R. We do understand that's a bit traumatic. We do have to get the radius of this circle. So now did I just flip it? Where did it have? Hello. There you are, mate. To do with getting the radius of this circle. So that's not immediately there yet. I'm just going to do it and then maybe backwards talk about it. Let's draw a little bit of a wavy line. Y equals 2x plus 1. And the other one we just found out the equation for is 2y plus x equals 17. If I can solve these simultaneously, I'll get this point. If I've got that point, I can use Pythagoras to work out the radius. Oh, that is quite small, I agree. You'll have to get your binoculars out. Do get those binoculars health and safety tested though before you use them, just in case there's any defects. But that's the strategy. Get where the two lines meet and then use Pythagoras to work out the radius. Where the two lines meet, what we're going to do, let's times the top one by 2, so it'll be 2y minus 4x equals 2, and that bottom one stays 2y. GCSE, all worthwhile in the end. What we do, bottom one minus the top one. This is simultaneous equations, by the way. If this looks weird to you, then I know what you're going to be doing tonight after this class is busting out simultaneous equations textbook, or at least a YouTube tutorial. That minus that. The y's go away, minus 4, so you get 5x equals 15, and x equals 3. Plug that back into even this one, and you'll get y equals 6 plus 1. I do know that one. So that's your point, 3, 7. And then it's just a case of using Pythagoras to work that out. Do I even need the calculator? Or maybe I don't, because along the bottom, what we're doing, we're going from 3 to 7, that's 4. And up the way, we're going from 5 to 7, which is 2. So radius squared equals 2 squared plus 4 squared. That's Pythagoras. R equals the square root of 20. So basically, that's it. I'll just write it out one more time, just for luck. Probably have taken a bit longer than I wanted today, but it's alright. It's nice to just get in there. So radius, so actually it'll be 20, because if the radius is root 20, then our circle, the right hand side has to be r squared, so you have to square that, so the actual answer is going to be like that. Cool. I'm just going to keep going. So we got that, and then what are they saying? This is an interesting one, so let's just go back to the picture. And yeah, they've said there's another line with the equation 2x plus k. And it's also a tangent. You know, you think it's a buy one get one free scenario, and I'm jumping in. Well, you might take you could probably get, I don't know, your nearest ruler or straight lined object and try and work out where this is going to go. Key thing is that's 2. Gradient must be the same. Gradient's the slope. So it can't look like that. It can't look like that. It has to have the same slope as that fellow. So the only option, if we do a bit of rollage, is over here. So there must be the one they're talking about. The only other one that could be a tangent is that. And they just want us to find the equation of it. All we really need to do is find k, by the way, where it cuts and we got it. A couple of ways to do this. I think the cheeky, sneaky, quickest one is if you just count down again. There's a little countdown pun, snuck that in, if anyone's still watching, who's a big countdown fan. Distracted me by saying that. Try and get back. Come on, focus, Paul, focus. Ha! It's looking a bit messy now, but if you count down again 2 and along again 4 from 7, 5, if you counted down 2, you'd get to 3 for y, and you'd get to 11 for x. Plug that in. 3 equals 22 plus k. K equals, what are we talking, minus 19? So that's it. Y equals 2x minus 19. Would have to be the equation of that guy. Monster recap would be just to say they've given us a line with an equation. They told us the gradient, they didn't tell us the y-intercept. Only other possible one where it can be a tangent and have that gradient is that line. We've got the gradient, we just need k, and if we can get this point where they meet, we can get k, because then we just plug it in. And that point where we meet, I just counted down. This is where the circle geometry stuff kind of gets interesting and useful, that convince yourself you can just do that again and you'll find another, you'll find the point on the other side, because that radius turns into a diameter. There must be 2 of them. So yeah, okay. Talking is finished on that one. Let's try a stats one. All right, we're going to do a stats one. It's long, word-wise, and it's weird if you haven't come across this thing before. And you know, in GCSE, there's limited stats in mechanics. It's not really anything. You maybe get speed equals distance over time, and you might have to do a histogram or 3, but they really do hit you hard in A level with this kind of stuff. So even if you have done this before, if you're A level now, like as in year 13, it's a good chance to recap and try and understand exactly what's going on with these and how to get the job done. I'm going. First one. It's probably, well, I don't know, it might take looks like it's going to take a long time, this question, but it might even be quicker than that other one. They have to put a lot of words in for stats to get it explained. They've said that, and they've asked what's the probability that x is bigger than or equal to 16. Well, probability that x is bigger than or equal to 16 is 1 minus the probability that x is less than or equal to 15. Now, maybe I'll bring this down a little bit so you can see what's going on in the calculator, at the risk of collapsing the whole structure. Oh, that could happen. How are we doing this? Maybe somewhere here. Number 7, distribution. CD, binomial CD. Variable. What's going in here? Some have said 15. For n, it's 40. So if you haven't seen this before or you still don't understand, that's all right. I'm going to do it first, and then we're going to have to do this again anyway, so I can go back and talk about it. 0.27, smash that in, and it comes out 0.949077. Just check I did that right. Put in 15. They're asking for the probability of 16 or more. Yep. Put in 40 and that, and yeah, it gave me out that. Okay. Let's go back to the calculation mode. 1 minus equals 0.050923. So that's quite a lot of decimal places, but I think let's keep it at that just to be super accurate. So what's happened? We'll start to see it when we go into the next part of the question. This is more just the computational getting a feel for it. This is the total number of whatever you're doing. You might be checking out 40 boats to see if they've got holes in them. This is the probability that there is a hole, so 27%, 0.27. 40 boats, checking are they punctured. And if you want to get a probability that more than 16 of them are going to be punctured, well, your calculator doesn't let you do that unless you've been in touch with IBM and got the latest funky stuff. Your average Joe like me in my Casio Class Whiz, it doesn't usually let you do above. So what you have to do is you plug in the stuff like I just showed you, putting in X as 15, it'll give you all the stuff, the probability it's less than 15, and you do 1 minus that, because all probabilities have to add up to 1. Okay, I'm continuing. So that was just getting you warmed up with hypothesis testing. I'll tell you what, I'm probably going to do it all and then maybe just try for a couple of minutes at the end to explain what's going on, because it might all seem a bit weird. I'd rather do it first before really trying to explain anything. And here they're saying, well, so something else is happening here. We're on to beans. Now, it's not my number one breakfast item. It's probably not even top 5, to be honest, but, you know, so I'm not totally inspired by it, but I do like the concept of breakfast, so that's keeping me going. They're saying that 30% of people who buy them in single tins. That's interesting. So they're saying they don't buy it in like a 4-pack, I guess. It's like, or do they mean the small tins? I don't know. Anyway, and the manager suspects there's been a change in the proportion of customers who buy them in single tins. And 20 people are getting a sample of 20 people is going to be tested. Okay, just going to tell you. The null hypothesis, otherwise known as H naught, is that the probability equals 0.3 or 30%. So that is, null hypothesis is the past records. That's what we expect to happen. We expect 30%, or the manager does anyway, or the records, that 30% of people are buying them in single tins. The alternative hypothesis, otherwise known as H1. Now, this could go 2 ways. Either it could be, it depends what we're testing. I'll tell you the answer to this one, and then I'll tell you why it could be different. The English language version of this is saying, has that 30% changed? Is it now more people maybe that buy single tins, or it could also be less? It's another hypothesis. We're thinking maybe the situation changed. It's not 30% anymore. It used to be 30. Things could have changed. The only other time this might be different is if, you've got to read the question. This one says suspects there's been a change. If he said he suspects there's less, it's fewer, then your alternative hypothesis would be is less than 0.30. You see what I'm saying? It's kind of an English language thing, converting it into mathsy stats stuff. But if someone thinks there's been a change, then it's no longer 0.3. If someone thinks it's now less than 0.3, then that's what you'd have to say. And it's subtly different how you have to go about it. So it's interesting. A couple of words in the question can change everything. That's our mark for there. Going on to C. Now it wants you to test this. Well, actually, first it just wants you to find the critical region and the probability of rejection. Okay. So my old backstory. Got the calculator handy again. Oh, and actually, before I do the backstory, let's put in a new binomial distribution for this one. That part A one was quite abstract. This one we've got beans. We've got beans to play with here. And it says the number of people being tested is 20. the probability that they buy single tins is 0.3. So that, my friends, is what your binomial distribution is going to look like. 20 people, 0.3% chance. Okay, and the other thing to mention here is 10% significance level. Now that's important. That's where these things become important. Because it's 10%, we're going to, and because it's a not equal to rather than a less than, we're going to split the 10 up. So what we're going to say is 5% at the lower end, 5% at the upper end. Okay, and before I do it, I feel contractually obliged to try to explain a little bit about what's happening here. Let me make this a bit slower, a bit smaller. Ideally without taking too long, but I don't mind if we go over a little bit. It's good to get this. So 30%. What is 30% of 20? 20 times 0.3 is 6. Alright, it's an interesting little thing to just note. So 30% is 6. So if they're right about the 30% thing, that means that 6 customers should buy beans in single tins, or buy a single tin, if they are right. This is what the records are saying. Since records began, the data suggests 30% of people. So if 20 people walk in and buy these beans, then 6 of them should have bought a single tin. All right, that's what you would expect from the data. What this is all about is what number of beans bought would be enough to disprove the 30%. You get me? I'll say that again. What numbers of beans could bought out of the 20 would be sufficient to disprove the theory that it's 30%. So, imagine one day, out of the 20 people that are buying them, maybe 7 people buy them in single tins. Or maybe 8 people, or maybe 5 people. Are these numbers really a big enough difference from the expected 6, such that we just throw away the 30% thing? Because you wouldn't expect it to be 6 every day. You would expect it to vary a little bit. It's going to go up and down. Sometimes 5 people buy a single tin out of the 20, sometimes 6, sometimes 7. So what this hypothesis testing is about, what number of these single tins would we need to see out of a sample of 20 such that we reject the 30% and say it's ridiculous. Because, for example, if out of the 20 it was like 19 or 18, we'd be saying this 30% is a joke. So anyway, that's a lot of talking, but I feel like it's necessary to get a bit of a backstory, and now I'm going to go with it. So yeah, this is the actual truth about how you do it. Distribution, binomial continuous distribution, variable, exactly the same thing again. Now, let's put in the n, it's 20. Let's put in the 0.3. Now, can I actually go back up? No, I'm going to have to press equals and then go back in. I am looking for a number which gets me either below 5% or above, up here in the top 5%. Let me show you what I mean. If it was 5 instead of the 6 that we're expecting, well, there's a 41% chance of that happening, or it being 5 or less. So up to 5, that's all right. We're not within the 5% threshold yet. So I'm going again. Now let's put in 4. If it was 4 tins out of the 20, chance of it being 4 or less is 23%. Still not in the 5% threshold. Going again with 3, 10%. Going again with 2. Ha! So let's write that down. If x equals, or x is less than or equal to 2, probability that x is less than or equal to 2 is 0.03548. And that is less than the 5%. Going again on the upper side. Let's just jump to 8 maybe, because we're going up from 6, right? 6 is what we expect. Chance of it being 8 is, well, there's still more than 10% above that. Chance of it being 8 or less, should I say. So, no, we're going to go again. Put in 9. Oh! So actually, already with that, I think we found a problem. Probability that x is less than or equal to 9 is 0.952. And the probability that x is bigger than or equal to 10 is 1 minus that. Should probably put in some more decimal places. And what does that give us? I'm going to have to go back and calculate. 1 minus 0.952038, 0.047926. So that is within the 5% at the top that we need. 10% significance level overall, 5% at the top and 5% at the bottom. So we can surmise from that that our critical region is either x is less than or equal to 2 or x is greater than or equal to 10. Just maybe just go back up a little bit here. You can see over it, hopefully. Yeah, even higher. That's better. So, mild recap of that, and we don't have much else to do actually. We've done the main stuff. This is the main bulk of it. The rest is just polishing it off at the end. But that's your binomial. 20 people, or 20 whatever, 20 tins, 20 chestnuts. You're testing a certain number of items. The important thing about binomial, you can only use it if there's 2 possible outcomes. I couldn't use this if it's what's the height of people in a class, more than 2 outcomes. I couldn't use this if it's how many goals were scored in a match. There's more than 2 outcomes. If this was a heads or tails, if it was like testing out of 20 coin tosses, heads and tails or something, I could use it. You can only use it when there's 2 outcomes. Here, it's either they buy singletons or they don't buy singletons. Chance that they buy singletons is 30%, 0.3. Would expect there to be 6 if there was 20 people buying them. 6 out of the 20, that's 30%. And what we've done here is we've worked out the number in a sample of 20 which would smash the 30% figure out the park. If out of the 20 there was 2 or less, it's smashed. The 30% thing is gone. Because what is actually 2? 2 out of 20, well, it's 10%, isn't it, right? So that would be 10%. And on the top end, well, 10 divided by 20 is 50%. But, so, yeah, that's the interesting thing. That's really the heart of this, is if it's just up or down a little bit above and below 6, it's not enough to disprove it or to reject the hypothesis that it's 30%. But what we've just statistically proven, or surmised, is that for a 10% accuracy level, if you like, this is a bit confusing, because it's not the same as these percentages. At a 10% accuracy level, this is the critical region. If x is less than 2 out of the 20, we'll reject the 30% thing, and if it's 10 or bigger, we also reject it. Okay, then it says, what's the actual significance level? Well, I'm probably not going to talk more about that. All we need to do is add those 2 numbers we had from before. (6,2). So yeah, that's for D, right? It's just adding the lower end probability and the upper end probability. So the probability that's down there is, yeah, I'm not going to write it out again, but if you add them to, add both the lower and upper, You get that. And this is where you really put it into practice. One afternoon, the manager observes that 12 out of 20 bought baked beans in single tins. Well, you've got your critical region at the top. If it's 10 or more, you're going to reject the original null hypothesis. And so you'd say something like 12 is bigger than or equal to 10, therefore reject H0 except H1. I mean, that's the Statsy kind of way of writing it and saying it, but it's better if you can understand it in the English language way that I said, really. If x is 10 or bigger, if there's 10 or more people out of the 20, then we have to say the 30% thing is not right anymore. We have to reject that. And here it was 12, so we do have to reject it. It's more than 10. And lastly, later it's discovered, oh, hello! The Scouts have been stocking up for their camping trip. Well done. It's pretty back to basic stuff. Toast. How could you make toast if you were camping? Can't really have a toaster. You probably have a portable grill or something. Could maybe do a job. Okay, yeah. And then it says comment on the validity. Well, so that's the part. There's a few tests. I think there's 4 tests for binomial. I already told you it has to be an either-or thing, where there's only 2 options. So either something's broken, not broken, heads, tails, something works or doesn't work. I don't know, there can only be 2 options. There's another one of the things which says it needs to be a random sample. So you'll check your year 1 textbook just to get the list of the 4 things for this extra mark. I'm not going to write it down actually, but what you're going to say is, if there's a group of Scout people coming in, this does potentially invalidate that 12 out of 20 thing. So maybe the model can still be okay, because the model assumes that there's none of this. The model assumes that the 20 things that you choose are all a random sample. It assumes that they're not like all Scouts absolutely mad for beans, or it assumes it's not the UK Bean Lovers fan club coming in to stock up, or it assumes that it's not a quarantine situation where people are going absolutely mad and panic buying beans. So any of those kind of extreme situations doesn't, I guess, necessarily disprove the model, because we're, for our binomial thing, we're just talking about the average normal random sample of people coming in. So that's it basically. I mean, I have already recapped quite a lot, but I feel like it doesn't hurt to just do one absolutely final turbo recap. I know we've been quite long today before I go, but I do think it's worth it. It's a complicated topic. It's good to try and understand. I mean, you need to be able to do the calculations, but also if you can understand it, even better. Here was a brute force calculation one to start with in part A. Probability that something is more than in a binomial, you have to do 1 minus the probability it's less than. You need to learn to put the stuff into your calculator. You can go back and check how I did that if you want. You could go back in this video and pause it and see what I put in. So we got that. Now we had Beanfest 2020, and what was apparently true was that 30% of people buy beans from single tins. That's the way to binomially model it if you're testing 20 people. That's the null hypothesis. That's just what I said. We expect it's 30%. That's the alternate hypothesis, that it's not 30%, that maybe it's changed. Maybe we can disprove that that's still true. What would the numbers have to be? What would the number out of the 20 have to be for us to say it's not true anymore? Well, that's what worked out. We had to do that by working out on our calculator, and you can go back and check how we did it. A 5% window at the top for probability, and a 5% window at the bottom. When we did that, we worked out the critical numbers were 2 and 10. That's the kind of bookends of this, where things start to go wrong. And then they suggested, well, there's 12 people, 1 out of the 20. Well, in theory, that's in this top area where x is bigger than 10. So in theory, that is bad for our model. Can't say it's 30% anymore. We're rejecting the null hypothesis. But you just got to check that everything was fair and there wasn't people stocking up due to quarantine or scouts off for some sort of adventure, but they should probably be doing that virtually in the current climate. I'm going to say goodbye. Thanks very much for watching. See you guys tomorrow. Keep sending me stuff. Keep sending me problems. Subscribe. Follow me on Instagram. I'm going to keep posting stuff. Let's get through these tough times together and come out strong. People starting A-level next year. People doing their exams 2021. Let's all get the momentum going, guys. Thanks for watching. See you next time.